Alright, you should be able to tell by looking at the form of this polar equation that we are going to deal with another Rose curve here. This time we have a sine function, and this time we have an odd n value, 3. So let's follow the same technique we did last time. Let's set 3 theta equal to pi over 2. This will tell us where we get all of those key points, the axis, the maximum, and the minimum. So divide by 3 to get theta equals pi over 6. So now we want to sketch in our cycle. Again, what is that 3 telling you? It's telling you we're going to go through 3 full cycles between 0 and 2 pi. And a quarter of our cycle will be pi over 6. So we know we're going to get a 2 and a negative 2 from the coefficient right there in front of the sign. And now let's go ahead and break up our axes. So there you have it. And now we're just graphing a sine function, which starts on the axis and then goes to its maximum, then back to the axis, then to its minimum, and then back to the axis. And repeat that pattern to fill in this sine graph. And there you have it. It looks a little frumpy at the end, but it is enough to see what we want to see. Alright, so let's follow the same exact technique as before. Let's take this and now let's turn it into a polar curve. And you might look at these, I don't know, call them, I guess these angle lines that I've drawn on my graph here on the right, and you might think that they look kind of weird. Because what about the pi over 3 values? Aren't we interested in those? Well, if you look at all those pi over 3 values, again, they all have an r of 0, which means they're just going to be at the pole. So look at those max and mins. Those are going to be the lines where we actually get petals. So let's get going, and let's see what's going to happen. So first point, when theta is 0, we are actually at the pole. So we're starting right at the pole right there. First key point then after the pole is at pi over 6, so we have an r value of 2. So at pi over 6, we're up here at 2. And I'll tell you what I'm going to actually do is I am going to double all these so we can make this graph a little bit bigger. So I'm going to say that, what am I trying to say? I'm trying to say that let's make this an r value of 2. So each circle equals 1/2 of an r. Therefore, like that would be 1, that would be 2, that would be 3, that would be 4, just so we can make it a little bit bigger. So there's my first one. When theta is pi over 6, r is 2. So there's my first point. And then what do we do after that? Well, then we go back to the pole. So I need to start at the pole, and I need to increase my r values out into that point. So that means I'm going to be curving up like that, increasing those r values. And then what happens afterwards? Well, then I curve back down to the pole. After I hit that pole, I'm going to continue down to pi over 2, where I have a negative r value. So if at pi over 2 I have a negative r value, I actually need to go down like that. Again, that value is 2. So all these values are going to be 2. So if I go to 2, there I am right there. And let's think about what this looks like. From that point, I'm curving down to the pole, crossing, and I'm hitting that point right there. Now, then I am going back up. I'm increasing my, how do I even say that? I'm changing, I'm distracted, I'm going from a big negative number to a smaller negative number back to the pole, and then up to 5 pi over 6, I have an r of 2 again. So I'm going back up to this point right there, but I'm first cruising through the pole, and then I hit it right there. Okay, what now? Well, then I just go back to the pole, and so I curve back down, and there you have it. And this is a little weird. Notice that it seems like we have a full closed shape there, but we're only halfway through that full 0 to 2 pi cycle. And what do you notice at that point? Well, at that point, everything repeats. So if I go through now and continue this, let's do so just to be certain we know what's happening. I'm going from the pole, I'm then going down to 7 pi over 6, where I have a negative value. So at 7 pi over 6, I am actually negative, which means I'm going up the pi over 6 line, going back to this spot. So I'm repeating over that line. And then what happens? Well, then I'm going up, back to the pole, up again at 3 pi over 2. I have positive 2. So I'm curving through the pole, and then I'm hitting that 2 at 3 pi over 2. So I'm tracing back over that line, and then I'm going back to the pole, and then I'm going down to 11 pi over 6, but it's negative, so I'm up on the 5 pi over 6 line. So I hit that pole, and then I'm actually going back up there, and then I'm going back to the pole, so I'm just cruising back down right there. So between 0 and 2 pi, when we go all the way around this polar graph, we actually retrace exactly the shape. So we went through it 2 times, and that's kind of interesting because we're tracing back over it. When we had an odd value there, when n was odd, we had n petals, as compared to when n was even, we had 2n petals, and we didn't trace back over anything, n petals, and we doubled it. So that's kind of interesting there, and there we have our rose curve.